So in this example, we're going to look at the normal distribution and using that to go from an x value to a percentage. So in the last video, we talked about general concepts in order to be able to do this. In this one, we're going to look at the example. So in our example, we'd like to estimate the chance our production plant is going to get a part completed in 3 to 5 days. Let's say I'm a sales rep and I would like to know what that probability is because I have a client who's asking and I want to be able to, with some level of certainty, know an estimate as I'm saying it without just having that, I'm just going to gut instinct this one. So we're going to use historical data for this. Bigger picture. So XYZ production plant, study their production for the past few years on how long it takes to produce a custom car engine. The times to complete their engine based on historical data appears to be normally distributed. So that's a key factor in being able to use the normal distribution to be able to do this. So that chart in the bottom left shows that it's fairly normally distributed. It looks like a bell-shaped curve. Not exactly, but close. The average time to complete a custom engine, we know from that same historical data, is 4.2 days with a standard deviation of 1.3 days. So we're going to take the fact that it's normally distributed with an average of 4.2 days and a standard deviation of 1.3 days to go ahead and make the next calculations. So in doing so, we are going to look at how to work this problem. So I took out that our mean 4.2, standard deviation is 1.3, we're normally distributed. Our event of interest, estimate the probability our production plant will take between 3 and 5 days. So we're trying to figure out what that probability will be. So let's go ahead. I'm using paint as this example just because I want to be able to write and show you what I'm doing visually on a normal curve. So we know that our mean is 4.2. We know our standard deviation is 1.3. So I could go ahead and fill those values in. But we know that we're trying to go between 3 and 5 standard deviations. So if this is 4, 3 is going to be somewhere in here. So we're going to say 3 is going to be right there. And 5 is going to be somewhere right in there. So we're interested in what is between those two values. What is the probability? What's the area under the curve? So the first thing we're going to do, let's go ahead and write in our 3 and our 5. So our 3 is right there. Helps when we write it in black ink. So our 3 is right there, and our 5 is right there. If we're going to go ahead and do this using the charts method or table method, we're going to first convert the x-score to a z-score, and then we're going to convert the z-score to a percentage. So when we look at this, let's convert the x-score to a z-score. So we know that the equation for z for a specific sample is going to be x minus, so your sample value minus the mean divided by the standard deviation. So we're going to take 3 minus, so 3 from the lower end, 4.2 is our mean, divided by 1.3, and we're going to say that equals then, so equals 3 minus 4.2 divided by 1.3. In this case, I use cell references. It doesn't necessarily matter. So let's say z is equal to then, in this case, let's go ahead and do the same one, except for we want to change it to a 5. So we're going to say it's going to be 5 minus 4.2 divided by 1.3. So it's going to be 5 minus 4.2 divided by the standard deviation of 1.3. We're going to get 0.615. So the z value associated with the 3 is a negative 0.92, and the z value associated with the 5 is a 0.62 rounded. So our z value of negative 0.92 and our z value of 0.62. Right now we need to convert those. Our next step is to convert them to a percentage. So we're going to use the chart in the back of the book for this one because we're using the chart method. So When we look this up, we're going between 0 and a value. Notice there's no negatives on here, but 0.92 z-score is going to be the same thing as a negative 0.92 z-score. So since our chart goes between 0 and the value, and we have a z-value of 0.92, we're going to look at a z-value of 0.9, use our 0.02 at the top, so 0.92 gets us 0.3212. So 0.3212. So our probability that we're going to be negative 0.92 standard deviations is 0.3212. Let's go ahead and look at 0.62 then. So 0.62 is 0.2324. Remember, it's from 0 to the value. So 0.2324. So from 0 to the value, so we are looking that up then. So this one's going to be 0.2324. In order to get the value, we're going to want to add the two of those together then. So calculate the answer. So the probability that we're going to be between 3 and 5 is 0.3212 plus 0.2324, which is going to be 0.3212 plus 0.2324. It's going to be about a 55.4% chance. Let's go ahead and do this problem using the Excel method. Well, in Excel, you don't need to convert to a z-score. You can actually go directly from an x value to a percentage value. So we're going to use the formula equals norm.dist. So we're using the normal distribution. We're going from an x-score of 3, and we want to know the associated percentage to it, so we're going to use .dist. Our x value is 3. Our mean is 4.2. Our standard deviation is 1.3. And cumulative is always going to be 1 when we do this one. So in this example, I was using cell references to do it, but essentially what we're going to be doing is, if it didn't have cell references in it, we would be using this formula in here. I'm going to put an apostrophe in the front of it so that my formula doesn't disappear. So equals norm.dist 3, 4.2, 1.3, 1. And we get that that's a 17.8% chance. So a 17.8. Well, when we do this, Excel is different than the charts in the back because Excel is going to go from negative infinity up to negative 3. So it's going to give you this score. So when it calculated it, it says that this value in here is 0.17, let's round it, 80. So let's go ahead and do the next one. So we need to do 5. So equals norm.dist with 5, 4.2, 1.3. That's our standard deviation, 1. And again, because I'm doing this as an example, I'm going to leave my formula there. So I threw an apostrophe in the front of it. So equals norm.dist of 5, the mean of 4.2, the standard deviation of 1.3, 1. We got 73% approximately. So what this did, again, it took it from this value here. So I'm going to change the color to blue for a second so we can differentiate these. So that took it from here up to there. So it's telling me then that this value in here is rounded 0.73, let's say 09. Well, I want to find the value between here and here, right? So I'm going to subtract the two of them. So the probability that we're going to be between 3 and 5 is essentially 0.7309 minus 0.1780. And when we do that, you're going to get equals 7309 minus 0.1780, we're going to get 55.3%. So 55.3, 55.4. The more of an exact answer would have been to use your values from up here and use cell references. So equals 73 minus 0.17, so 0.55286, so 0.5529. Keep in mind, when we're using the normal distribution to do this, is somewhat of an estimate anyway. So if we said 55.3 or 55.4%, we would be probably all right with it. So our conclusion on this one is that it's going to be a 55.3% chance that it will take between 3 and 5 days to complete our custom engine. So as the sales rep then, 55% is good. We're more than likely to finish, more than 50%, but there's still a 45% chance that we might not be done in that 3 to 5 days. We might finish it sooner, we might finish it later. So it'll be up to you as that sales manager then to go do our sales rep. Do I really want to use that 55%? I can use it for my own purposes. Do you share it with the client? So those are the points in decision making where you need to make those decisions. Next video is going to cover how to go from percentage values to X scores.